All right, so clearly this should be example 3, not example 1. Sophie has 10 pots labeled 1 to 10. Each one, its contents is identical in every way. This is their way of telling us that it's independent events. So this is my n value. I have 10 different things that are exactly the same. That's like the same as flipping a coin 10 times. Plants a seed. Each seed germinates, probability of 0.8. So that is my probability of success. Okay, what is the probability that all the seeds germinate? So that's the probability that x is equal to 10. So then I'm going to have 10 choose 10. Of course, that's just 1 times 0.8 to the 10th power and 0.2 to the 0 power. That's the same, of course, as just 0.8 to the 10th power. If I hadn't told you this was a binomial distribution problem and just asked you to figure this out, you would have done the same thing. You would have said the probability of germination 10 times is 0.8 times 0.8 times 0.8 times 0.8, a total of 10 times. Same exact thing. The probability that only 3 seeds will not germinate, that's the probability that 7 will. All right, so that's going to be 10 choose 7. Goodness gracious, down in the next line there, 10 choose 7. And then we've got 0.8 to the 7 and 0.2 to the 3rd. So exactly 3 not germinating. And I can put that in my calculator. I could also use the function we figured out last time. So that's in second vars. And then up to binom. Here I want PDF because it's an exact probability I'm looking for. Okay, our trials are 10. Probability of success is 0.8. My x value is exactly 7 that germinate. Wow, big number. So I'm going to round this one 0.201. All right, more than 8 germinate. So probability that x is greater than 8, same as 1 minus the probability that x is less than or equal to 8. That lets me use my binom CDF, 1 minus distribution, binom CDF, too far. Okay, same thing, 10 trials, 0.8, my x value also 8. Okay, 0.376. All right. How many pots does Sophie need to use to be 99.99 sure that at least 1 seed germinates? So how many pots? Now we're saying we don't know what our n value is. So we want the probability that x is greater than or equal to 1 is 0.9999. That means 1 minus the probability that x is less than or equal to 1, less than 1, is equal to 0.9999. All right, so that means the probability that x is less than or equal to 0, we could say. Of course, that's just going to be x is equal to 0. So exactly equal to 0.0001. All right, so I'm going to solve this. That's going to be n choose 0 times 0.8 to the 0 power, and then times 0.2 to the n power. N choose 0 is just going to be 1. So I want this to be equal to 0.0001. So 0.2 to the n, 0.0001. Oh my goodness, we are back to a log problem. N is log base 0.2 of 0.0001. Put it into my calculator. Hopefully you remember this, but maybe not. Alpha, ooh, maybe I don't remember. Alpha window. Look at that, log base, 0.2, and then 0.0001. All right, our n has to be an exact value, so it needs to be at least 6 pots. So n is about 5.7. Therefore, we say n is equal to 6. So she needs at least 6 pots so that one seed germinates.